So as you can tell, we are running a little bit behind. What we're going to do is I'm going to go through my content exceedingly fast. So if I'm going too fast or you're not understanding, start waving your arms and all that kind of stuff, but otherwise I'm going to have to go really quick. So my name is Blair Layton. I've been working at AWS for 5 years now, and I look after our database services. So what's a database guy standing up here talking about the scaling applications for large promotions and events? Well, as you'll see as we go through, the database aspect is one of the key components that we have to look at when we are scaling these applications. So, first of all, we need to say, what is a large-scale event? Well, it could be something where you need more capacity than you've normally allocated to your environment. It typically could be from minutes or days, but could be a couple of weeks. Like if you're doing an e-commerce site and you've got a promotion for a couple of weeks, then you might need a lot more capacity during that time. And it's often associated with a sudden surge of users. So what would happen is if there's a promotion and you open that promotion up at midday, then of course everybody's going to come in exactly at that time to try and get whatever it is that you're offering. And it's very hard to architect for these types of problems. And you don't even know if you're going to do a promotion necessarily how many people are going to come in and actually go and use the system. So the thing is that even though you don't know how to architect well for the right number of users and everything, if you get it wrong, it gets pretty nasty very quickly. So this is definitely something that was a large-scale promotion and event. And if anyone remembers the iPhone 6, well, what you were actually doing is for the first time we had the bigger version of the iPhone. And I don't know about you guys, but I'm actually an Android user, and I've been using big phones for a long time and always making fun of my friends with Apple phones. And they said, no, the Apple phone, you need the right size, and then you have an iPad and you have your Mac and everything all together, right? And then, of course, when the big iPhones came out, my friends were like, yeah, this is great, I've got the big one now. So how's the iPad? And it's like, don't use the iPad anymore, right? So anyway, this was huge, right? A lot of people wanted these phones. A lot of people came in to try and buy them. For India, cricket is king, right? The IPL is very, very important. What happens when an IPL game is on? People are going to be going to the IPL website, or maybe you go to Dream 11, you've got your fantasy team, and you want to see how they're going ball by ball and what's happening. Outside of the match time, not a lot going on, right? So there's a huge amount of users that come in at that particular time. I found this quite funny. I was looking for how do you book tickets here in India, and then there's this Boys Life. Okay, that was interesting. A boy band come for the first time in India coming. But sometimes you could have something popular and it's a ticket sale and they release the tickets at a certain stage. Then people are going to go and say, all right, I want to go to that concert, and that's going to be a big event as well. So for you, it could be as simple as just needing twice as much capacity for a short promotion. But fundamentally, the concepts of whether you're launching an iPhone 6, you're running the IPL, or anything like that are essentially the same. So we're going to go through those core concepts. So the problems that you have, the first thing is, how are you going to actually plan this out? You don't know the infrastructure. How much cost is going to be associated with that? The short duration of the event means that you're not going to go and buy all of this kit, put it into your data center, and then sell it again afterwards, because people don't particularly buy second-hand IT kit that are great. Legacy system integration. If you've got this new whiz-bang stuff you can put out on the web, but what if your payment system is still clunky running on old hardware on-premise? How are you going to manage that? And understanding the system behavior, you need metrics to understand where are my bottlenecks and where do I need to scale things out. So you need to get the right architecture and you need to get the right talent. And you certainly don't want this. So this was a funny article that I saw, that you guys must do your tax, and then it breaks down basically every time, right? And there's this funny article saying that in 2050 the government is still not able to fix the system. So one question is constant. How do we scale, especially the database? So let's start from day one, and this is user one as well, right? So just you with a simple stack. Here we've got a full stack on the host. It's got a web app, a database, management, etc. Everything on one EC2 host going out to a Route 53 service, which is DNS, so that you can see the server and get access to it. And then you're just managing that, building out that app. So eventually you're going to say, right, well, we've got users coming in now, we're going to need a bigger box. But at some point, even though we've got a lot of different instances, you are going to hit limit, and you're not going to be able to scale past that point. So then we look at this and we say, right, we know we've got this box, we can get a bigger box, but we've got other issues as well. No failover, no redundancy, and too many eggs in one basket. So what are you going to do at this point? Well, first thing is, let's separate out the database and put that into another box. And do we want to make sure that we can use something like a database service? So on AWS, we have a database service, and you have to at this point then say, are we even using the right database? So start with the right database for the job. That means that if you've got skill sets in, say, SQL Server, and you're doing a .NET application, that might be the right database to start with from a productivity perspective. However, if you know that this is going to be exceedingly scalable, that you are going to have millions of users, and you can see that NoSQL might be the right choice for you, then by all means go down the NoSQL path, even if perhaps you don't have the skills, because you simply know it's going to be a requirement. Most people can start with relational, and as you start to evolve your application, you can find components and things and break them up, and we'll talk more about that. So decide wisely at this stage, because you're making an investment in a technology that's going to be the foundation of your application. And look for those key points of scale, as I mentioned. So now we've got the architecture with RDS. So we've got a master database, we've got the web instance, and then we've got the application running off that. At this point, two things happen. The application will actually respond slightly slower because the database is now on a separate machine and you have to go across a network. But now we've got a much more capacity for the database to execute on and much more capacity for the web tier to execute on because they're on separate boxes. So you're going to be able to serve more users at slightly slower performance. So when you get to over 1,000 users, we have to look at redundancy. How are we going to actually address this? Well, we have a great service for load balancing, and when you put a load balancer, then you can actually have servers in different availability zones, so different data centers. And then we can also have what's called a multi-AZ service as part of RDS. And what this is the capability to have a master and a standby in different data centers, and they're going to be kept synchronously up to date. So that means if something's committed on the master, it's guaranteed to be committed on the standby as well. So if something goes wrong, we will automatically fail over to the other side, and there'll be no data loss because the data is consistent on both sides at all times. So then we want to move to more than 10,000 users or more than 100,000 users, or up to 100,000 users. How are we going to actually scale even further? Well, now we've got more web servers in the middle tier. We've introduced read replicas. So with read replicas in RDS, it's very simple. For MySQL, for Postgres, and Aurora MySQL and Aurora Postgres, you can simply say, yes, I would like to create a read replica, and we'll go and do that for you. A couple of clicks on a menu, and off you go. So this is going to allow you to protect your master database for writes, and then be able to scale the reads out onto the read replicas. And this, once you're at this point, will actually take you pretty far. You'll be able to scale to quite a lot of users and happily serve that, and it will operate very well. But it's not as efficient as what we would like. So we're going to clean it up a little bit. So we want to shift some load around. So what we've done here, as you can see, we've introduced one database here called DynamoDB. This is a NoSQL database. And over here, we've introduced Elasticache. Inside Elasticache is a caching service where you would have Redis or Memcache. Now, what you are doing here is offloading different components of your application to the right database for the job. You'll also notice that we've introduced S3, and then at the top, we have CloudFront. CloudFront is our content delivery network. So now we're taking static content and moving that into S3 and delivering that from the edge of the network through CloudFront. That's going to take a huge amount of load off the web tier. So now we've taken load off the database tier with a cache and NoSQL database, And then we've actually taken load off the web server tier by removing static content and putting that into the edge network. So what are the kind of scenarios down the bottom there of where you would actually use a cache? So typically what we see is when you have just a relational system, you still need to persist session state somewhere. That is stuff that can be rebuilt often, or a user just has to come in again and then we create a new session. So for that type of thing, you can put that into a cache. Now, if there is something like, if you go to Amazon.com, for example, and you're going to buy some products, then you put those into your basket, and then you look at that inside that, you come back 3 months later, and then the stuff is still there. That's because it's being persisted. This is not going to be persisted. This is definitely persisted. So you could have some components like a shopping cart where you're going to persist that data into a NoSQL database. So you choose which component makes sense to come out and split that out and deliver that in each different database. Now we're at more than 500,000 users. At this point now, we've got the different types of services. We've got CloudFront in there. We've got S3 delivering the static content to CloudFront. We've got DynamoDB, Elasticache, Read Replicas. It's all across multi-AZ. This is pretty cool, right? You're going to be able to serve a lot of users in this environment. So then once you get past this point, what do? It's time to make some pretty radical changes, because that architecture that I just showed you before is fundamentally what most customers, once they get pretty optimized on AWS, end up running. But they invariably will get to a point where they get stuck. And that means that the database is not scaling anymore, or there's too many dependencies in a monolithic application. So the thing that is logical to do next is to start adopting microservices. And this is where you're going to take that monolithic application and start to split it up so that you can scale those components independently. So, and Amazon.com and AWS do this extensively. We could not build the scalable systems that we provide you today without using the microservices approach. We simply would not be able to deliver for the number of users that we have today. So how do you do this? Well, the looser that you're coupled, then the bigger they scale. So you have different components which are held together with queues. And as something finishes, so in this case, you've got a queue feeding into controller A, it's looking for what's on that particular queue, processes the work, does what its results, and put that on the next queue, and then controller B comes along. Now, in the tight coupling, you simply have controller A calling controller B. And if those have a problem at any point, then either controller B is not doing anything, or control A is also waiting perhaps on something calling it, or it's trying to call B and that's not working. So you've got a very strong case of failure here. Now, in the case of the queue, then there could be plenty of work on the queue for controller A to do while controller B is perhaps scaling up or doing something else to recover from an error. So it means that you're still going to be able to get some work done, and then when controller B comes back up, it will be able to look at the queue and process that because it's now scaled up to do a lot more activity. So here we've got a nice modern architecture. You can see that what's changed. Now keep in mind that this little orange line here is the availability zone, and we've just got one. Remember, we did want to have two for availability, but because of the complication in terms of the level of architecture that we need to demonstrate, we've just got one at the moment. But now we've broken out an internal application, which was part of the monolith, into a separate set of instances. We've also broken out some worker instances. Now, what are worker instances? If you've ever uploaded a video to YouTube, you will put your metadata in, describe what the video is with a title and description and so on, and then you will actually say, okay, yep, I'm ready to go, upload. Now, in the background, it might say, hey, we're still processing your video, because the workers for YouTube, for example, will be processing, say, a 1080p video and creating the 720p version, the 480p version, and the 360 version. All of that can be done in the background after you've actually uploaded that initial copy. And then you'll find that, eventually the different versions will be available for you to play that back in the YouTube console. So this is the type of thing that you could do. So these worker instances for your application, maybe they're doing things like creating thumbnails for images. Who knows? Could be anything that could be separated from the main flow of the application. And you see we've added other services there. We've got the queue service now to manage the queuing, SQS. We've also got the simple email service so that you can send email out. And we've started to take advantage of more of the platform. The next big steps. Once you get to this stage, you're going to do 5 to 10 million users. You still may find that the database can no longer cut it. You might have to actually take different strategies. So the first one is federation, where you start splitting multiple databases based on function. And that's kind of similar to breaking up a monolith into microservices, if you like. Sharding is kind of like, people hear this, oh, Twitter does sharding, or Facebook does sharding, or everything, I should do sharding, right? Sharding is really hard. If you're going to split your data across multiple databases, and then you've got to have application logic that manage that as your databases grow, and then you're going to have to split them again. You're going to have to query across all those databases. It's very, very complicated to do that. You should only do it as a last resort. And then, of course, moving some data into different types of databases, as we've kind of already done, taking that to the next level as well. Then the other thing is you really need to have good metrics in your application. If you're looking at the metrics for your application, you will be able to identify bottlenecks. And when you can identify bottlenecks, then you can work out which components you need to scale. If you're looking at systems, and especially when you move to microservices, and you don't have good logging in place, it becomes very, very difficult to debug a distributed system and to monitor a distributed system. So do make sure that you put all of this in one place and that you actually have the capability to analyze that and look for patterns and look for problems. So then you can look at things like, for example, let's say somebody wrote a component of a microservice in PHP and it's not performing very well. Maybe you decide to put that into C++ to get that extra performance because it's a very compute-intensive workload and you need it to be as efficient as possible. That's the type of thing that you would do at this stage. So let's look at some customer examples. So here we've got Goomy Asia. So they are a Singaporean gaming company. They have their parent in Japan. And in Japan, they launch their games fundamentally for the Japanese market. And then Goomy Asia releases the games for the rest of the world. They have also done games for Disney, for example. When some of their films come out, they have actually done a game associated with that particular film. And the last one that they did was Big Hero 6 when that came out. So the problem that they have is promotions cause huge spikes in activity, right? You send out something on your phone, and then you get the notification, and you're like, oh, yeah, I really want to go and play the game now because I'm getting a free gem or a free coin or something like that. And then everybody comes in at the same time. So auto-scaling works for the web tier, but the RDS instances were always sized at the maximum size to deal with the peak workloads. And what they did is they adopted our recommendations in a staged approach. So if we look at the architecture of what they had first, at the very top they had CloudFront, Route 53, then coming through into EC2 in a auto-scaling group, and they had a multi-AZ database, and they were using CloudWatch to record all of the different logs and things around the metrics for the different systems. Now, what we had them do originally is they put in a read replica. So this read replica allowed to protect their master database, and they were able to scale that to the next level. But the game was still getting more and more successful. So then we said, well, what is the primary bottleneck? We looked at, what's happening in your application. And the bottleneck was primarily around the user management, because remember, they send out a notification, everybody decides to come in and play the game at that same time. The first thing you do is log in as part of the game registration, right? So what we did is we put the user management into DynamoDB, super scalable, NoSQL database as a managed service. And that protected the relational database from that surge of users coming in. The next thing we did is add in Elasticache Memcache for session management, and then we added in Redis as well. Now Redis has a key capability called ordered sets. For gaming companies, that's really important because you have leaderboards. And a leaderboard is essentially an ordered set of results. So from Redis, you can simply pull the top 10 users and blast that on a web page or inside the app to show who are the top 10 results, either across the world or across a group or your own personal top 10 scores. Then they also, at this time, added Amazon Redshift to do analytics. And this was the final architecture of what we actually told them to do up front, but they ended up doing that in a staged process. So what are the lessons that we learned? Listen to AWS Business Development and Solution Architects. That's us, right? We've had experience in doing this for a long time. If you need advice, do listen to us, but please take that advice because we've seen it work at other places. The gaming promotions became much easier to handle. And the unpredictable loads also worked much better. So sometimes they just had a huge burst on the system and they didn't know why. It wasn't through any marketing that they did. It was maybe someone created a blog and people picked up on it and said, oh, I want to play that game. But they didn't know where it came from. And a senior operations person, and this guy, because I was working closely with this, he was getting woken up at 3 a.m. having to reboot servers and reconfigure things and doing all sorts of stuff. He was able to move on to another project because this became completely stable, even though it was operating at the highest levels that they'd ever had. And then most importantly is the customers got a much better gaming experience. So a telco. So we're talking about phone launches. So in Singapore, this particular telco does launches for new phones. So they first came to us with the iPhone 5S and 5C, and they wanted to make sure that that was going to be really successful. And they needed to handle a large number of concurrent requests because they literally opened the system at a particular time in the day and everybody would come in to load this in. They'd failed previously on the iPhone 5. If you went to their Facebook page, it was pretty horrific in terms of all the comments and things that were there. So they wanted to succeed at all costs. So we built an architecture that you can see here that does not even have a relational system. It purely uses DynamoDB with a cache. And the cache was there to protect Dynamo from the reads, because the reads were the most frequent thing that was happening. And then once something actually ended and the customer selected their phone and so on, then we would push that and then update DynamoDB. Okay? So this was very, very scalable. But what was interesting about this is it's not just about the architecture of the infrastructure. We also architected the application in a way that fanned users out by having a series of screens that you can have, for example, put in your Singaporean ID and then check, are you able to actually get a new phone? Then select your phone and your appointment, then put in your personal details and then confirm everything. By splitting up the way the application worked, you're fanning the speed of the users out so that they're arriving at different times. Because you can imagine the 16-year-old girl who's absolutely hungry for the latest iPhone, she's in there at 100 miles an hour. Whereas grandma at the moment, she's like, I really want that new phone, but I'm just going to put my glasses on. And once I get my glasses right, then I'm going to start typing with my 2 fingers, right? So you're going to fan those users out very quickly by having the different approach. And of course, some people are very good at using keyboard and they might see there's a shortcut for the next bit and they push that on the keyboard. Other people are going to go to the mouse, get the mouse, drag the mouse down and push the button. So there's different ways that you can actually manage the scale of applications from the physical infrastructure and the technology choices, but also in the way that you architect the application. So, great success. Tested with 150,000 concurrent users. All the phones were gone within 2 minutes. No phones were misallocated or anything went wrong. So we went back to the management team and they said, oh, that's too fast. Okay, but at that stage it was so close to launch that we couldn't change it. And the actual launch went smoothly. There was no major drama. So what management was concerned about here is that even though somebody had started the process, that they would not get a phone at the end. And that's a legitimate concern. Because what would happen is with each screen, we were checking, are the phones all available? And you could still get to the last screen and then say, oops, no, that phone is now being removed from the system. So lessons. AWS can provide infrastructure for applications to scale to very high concurrent users. We've got managed services that allow you to quickly deploy changes to infrastructure. So for example, on that telco example, they just started with DynamoDB and they didn't have a cache. We suggested they introduce the cache and they said if it wasn't a managed service, they wouldn't have been able to introduce it in time and make their changes to the application. It's impossible for the customer to do this internally. They would have had to purchase so much equipment and then it would have been sitting there idle for most of the time. So huge cost savings, even though they over-provisioned massively to make sure there was no issues. And now they've even taken this system and improved and changed it for their needs, including the flow of the application to make it more user-friendly for their customers when they launched the iPhone 8, which again went well for this particular customer. This is another customer I've worked with out of Taiwan, and they do ticket sales, so for concerts and events and so on. So with our systems on AWS, we can scale our resources more than 130-fold in 30 minutes, enabling us to support more than 2,500 orders per second. So again, in the ticket sales scenario, they have their daily business for events where people are just buying tickets, and then they release some amazing Mandarin pop star or Cantonese pop star or something who's visiting Taiwan, and boom, everybody wants to go in and get that ticket, so then they have a huge spike. Thank you very much. Hopefully that's given you a great idea of how to scale your applications.